Jay is returning to present the IEDB Query API, which is also called the IQ API for short. And we've spoken in yesterday's sessions about APIs before, particularly in regards to the tools that we showed, but today it's very database specific. And this was a really big initiative that was requested by the NIH, who funds the IEDB. So this was a really exciting piece of work that the team put together with the support of the NIH. So we thank them for that. And with that, Jay, I will hand it over to you.
Thanks, Nina. Excuse me. Hi, everyone. I'm Jay Greenbaum, and I'm happy to be able to share with you the IEDB Query API, or the IQ API. As Nina said, this was a project that we released, I believe, either last year or the year before, and it's definitely gained traction over the past couple of years, and I'm excited to show you how to make use of it. So first, we'll start off with what is the IQ API and why does it exist? And first of all, just defining what is an API. And so API just stands for Application Programming Interface, and it serves as an alternative query interface to the IEDB, with the content completely identical to what's in the web-based version, but the format that you get is a bit different, and the use cases are a bit different. So here's a typical user that interacts with the IEDB web interface. They'll fiddle with the controls to enter their query there, and they'll hit search, and that will hit this backend database, which will return the results to the web interface where the user can see them. But what the API does is it provides an alternative route to the database, where a user can use HTTP calls or write a script around queries based on this PostgreST syntax. So we put a PostgreST server in front of the database for users to access. And as I mentioned, so I think we've had it up maybe a year and a half or so. And over the past 6 months, we've seen about 850 queries come in per day, hitting this API interface. And so we can talk a little, sorry about that. So we could talk a little bit about how it works. It all starts with this base URL. So every query begins with just going to this queryapi.iedb.org URL. And there you'll find the documentation for how to hit the different endpoints or the different tables. So each of the database tables that we have is exposed as a different endpoint. So if you're looking for epitopes, you would use the epitope search endpoint. For T cells, T cell search, and so on. So that's the second part of your query. Is first the base the base URL, and then the name of the table that you're looking for. After that, you can restrict your queries by adding additional parameters onto the end of it. So for instance, if you want to limit your query to searching for the linear sequence that is the synfecal sequence, you would add onto your query string linear sequence equals, and you have to use the PostgreST syntax for equals, which is eq dot, and then the name or the sequence string. Then when you put it all together, it looks something like this. And you can take that, you can put that in your web browser, and it will bring you to a page that will return a JSON response. And you can also do that from the command line with the utility like curl or in your favorite programming language. And when you do that, you'll get a response that looks something like this. So you have a JSON response where you get one row or one record per hit. So here, we're querying for epitopes with the linear sequence synfecal. And so we get 3 records returned. We get 1 that's kind of like the base sequence. And then we get 2 records that have sequences with modifications. So that's querying epitopes. Now, if we want to query the related T-cell assays, we can enter a very similar query. So instead of searching the epitope table, now we're searching the T-cell search table. And we're using the same query string. We're looking for T-cells, T-cell assays that have profiled epitopes with the linear sequence synfecal. And so now, instead of 1 row per epitope, we're getting 1 row per T-cell assay that's associated with the synfecal sequence. And so we get a response that looks something like this. That's more assay-centric instead of epitope-centric. And so most of your queries you're going to want to refine. The tables by default, if you just go to epitope search, you'll get a response, but you'll get a gigantic response. The epitope search table includes, I believe, over 70 fields. So for every record that's returned, you're going to get 70 values. And some of those fields are list fields, so you'll get a gigantic data set back. And you probably want to refine that in some way. And so you can do that in one of 2 ways. Well, there are multiple ways, but you can do horizontal filtering, where you could kind of trim down the fields that are returned instead of getting everything back. And to do that, you add this select parameter onto the end of your query string, and you specifically name the columns that you want returned. So here I'm saying I only want return the structure ID, structure description, source organism names, and parent source antigen names fields. And so when I get the response back, it goes from something like this to something more manageable. And so you can use the documentation to see all of the different fields that are in the different tables, and just selectively pull the fields that you care about, or the meaningful fields. And another way to filter is vertical filtering. So instead of shrinking down the number of columns that are returned, reducing the number of rows that are returned, the number of records that are returned. Again, if you just search the epitope search table without restricting it at all, you're going to get more than 1 million records back. And maybe you want that, but you probably don't. You probably want to refine your search in some way. And so the way to do that is to name the field that you would like to restrict it on. So for instance, the example that I've been using is searching for a specific linear sequence. And when you do that, it's only going to return those records where the linear sequence matches your query string here. So you go from having 1 million records returned down to 3 records. And so PostgreST provides a really rich syntax for executing your searches, for restricting your results. If you go to the PostgreST documentation page, you'll see this nice table that lists all of their different search operators. And if you could do it in SQL, you could do most of the things you could do in SQL with PostgreST. So there are all of these different search operators here. There are a lot, but I found that with just 2, you can do a majority of the queries that you might be interested in. So we've already looked at this EQ dot operator, and this operates on string fields and numeric fields and just looks for equality. And so it's used like this: linear sequence equals EQ dot, and then the string that you're searching for. And then there's the contains operator. So the contains operator operates on list fields. So there are many fields in the database that are lists. So for instance, in the antigen table, an antigen is associated with, or can be associated with many epitopes or many linear sequences. So if you want to search for linear sequences, you can't search for equal because it's not a string. It's a list of strings. And so you would search, if you want to search for linear sequences that are, if you want to search for antigens that are associated with the synfecal linear sequence, you need to search inside that list. And so you would use the contains operator, which is just CS dot, and then you put your search string inside these curly braces. And yeah, that's how that search operator works. So yeah, I find you can pretty much get by with EQ, contains, and maybe the contained in operator also. And I haven't needed to use too many of the others, only in special circumstances. And so the way that the tables are laid out, the queries are really, really similar across the different tables. So if you want to pull out the related information between the tables, you really kind of only have to switch between this EQ and CS operator. So for instance, if you want to search for the synfecal epitopes, you do linear sequence equals synfecal, but then if you want to find the antigens that are associated with the linear sequence, all you need to do is change that to linear sequences, plural, equals CS dot synfecal. And we've carried that throughout all of the different tables to make it pretty easy to switch between them. So what are the use cases? Why would you want to use the API? I mean, there are a lot of reasons. These are just some of them here, but it provides you direct access to a computer-friendly format. When I didn't mention, you can also specify you want TSV format back as well. And so, so a human-friendly format that you could then work with in a spreadsheet program. And you can do all of that without the web interface. It'll allow you to incorporate queries into your code, so you can, for instance, have a job that runs every couple of weeks that checks for new data with the same query. And you can do that in your language of choice. So I'll show you in a moment, but in just about every programming language, there is a way to get this done. And that will help you to be able to link between the IEDB and other resources as well. So in terms of the content that you can query, if it's in the web interface, it should be available through the API. Over the past year and a half or so, we have come across some fields where we know they're in the web interface, and we go and search for them in the API, and we find that they aren't there. If you come across stuff like that, let us know, and we'll try to find them. And if they're not there, we'll try to make sure that that we get them in there. So you should be able to search across all of these, basically all of these tabs that you would normally find in the web interface: epitopes, antigens, assays, receptors, and references. And this is where you would go to find the documentation. This is a semi-automatically generated documentation that uses the Swagger interface. It's really nice because it gives you an overview of all of the different tables, so all of the endpoints that are there. And within each table, there's a description of the table and then a description of every single field that's in that table. And it also allows you to interact with the API in real time. So you can test out your queries, it will build URLs for you, and it's a good tool to kind of fiddle with the API and learn how to use it. And so if we try to reproduce a website query through the API using that Swagger documentation, I'm just going to continue with that example that I've been using since the start. So in the web interface, if we want to search for the synfecal epitope, what we would do would be enter that sequence in this linear peptide box. The corresponding way to do that in the API interface is to find this epitope search endpoint, find the linear sequence field, and enter synfecal using that EQ dot operator. Right, just like that. Once we do that, and we hit execute, we'll get a response that looks like this. It will show us the URL that it created, and it will show us the response from that URL in JSON format. And like I mentioned, if the programming language that you like supports GET requests, and most of them do, you can get this done in just a couple of lines of code in that programming language. So Python, R, JavaScript, Perl, all the programming languages have libraries that can make GET requests. And so if you want to find out more about this API, you can use the Swagger documentation. And if we have a few minutes, I might walk you guys through that in a minute. You can also go to the PostgreST reference where you can learn a little bit more about all the different search operators. And we did put together a few use cases that are in R Markdown and in Python Jupyter notebooks. Some of those are semi-contrived use cases, but some of those are also actual user use cases where they've filed a Zendesk request and they've asked us how to get something done in the API. And instead of just answering them, we put together a use case for everybody. And then also, we do have a nice help article on Zendesk that explains some of the finer details of working with the API. And this is the team that worked to put it all together. And do we have a couple of minutes? Because I can show a quick demo.
If you don't mind, Jay, we have about 10 minutes extra. So yeah.
Awesome.
Thank you.
So let me just stop sharing for a second, and then I'll right window. All right. So are you able to see my browser?
Yes, that looks great.
Okay, great. So this is the interactive Swagger documentation that I mentioned. And Zoom controls are in my way here. Okay, so it's at queryapi.iedb.org/doc/swagger. And if you scroll down, it lists all of the different tables that you can query. And if you open them up, also, first of all, it gives you a description of each table. But then when you open them up, it will show you all of the fields that you can get or that you can query. And so for instance, I'm just going to continue with that silly example. We'll search for Synfecal here and scroll all the way down through all of these fields. And I'm going to hit execute, and this executes in real time. There we go. It gave us a response. And okay, so we got an error here. And the one thing is, it gives us some really nice error messages. So it says failed to parse linear sequence. And this is because we forgot to use that search operator. So let's go back and fix that. And almost there. Okay, there we go. So EQ that. Execute. And so it shows us again the URL that it's hitting, and now this is the response. So we can also just take that URL and we can put it in a new tab and hit enter, and you can see it gives us this JSON response with those 3 items. Again, if we want to filter by specific fields, if we only want a few fields returned, we would just add on to that and select equals, so structure ID structure. I can't see my text right now. These descriptions, right? And so so it's that simple to just select the fields that you like. And so we put a couple of use cases together. This is what they look like as Jupyter notebooks. So again, this one just goes through using Python Jupyter to query the API, and it's really simple to do so. And it just shows you how to query the epitope table and turn those queries into pandas, or turn the results into pandas data frames, and either do your filtering in the with the API or do your filtering in pandas. And then we have a bunch of other use cases as well. And yeah, I think I can stop there. Thank you.
Thank you, Jay, so much for not only the presentation, but the somewhat impromptu live demo, which is fantastic. Thanks for filling in the extra time that we had. And I'm going to give Jay and Marcus a little bit of time to go through the Q&A, because the questions are coming in, and just to provide a few updates, because I think both of these projects really exemplify some of the strengths of the IEDB resources and teams. So in terms of the 3D viewer work, this project came about obviously through the pandemic, and one of the needs were to be able to visualize mutations within the sequence and visualize the structure for the spike glycoprotein. And so that's where we started. It started in a very niche and specific place. And then we realized, well, we can actually expand this viewer into many different places and improve the way we visualize 3D structures overall, not just for, a spike for SARS-CoV-2. So that is one example of how one small, task can turn into a larger project where we're able to improve our resources. And that's kind of happened a few times. And then somewhat similar but different, the API project came about from something that was actually on our 7-year roadmap that we always wanted to do. It was a highly requested feature from our users to be able to programmatically query the IEDB database. But this was really, I think, accelerated is probably the right word, because of the support from NIAID, our funding department at the National Institutes of Health. So something that we always wanted to do, but really didn't have the immediate resources, we were able to do much earlier and in a better way. And now we can see the benefits much sooner. So again, that appreciation that we have to our funding source as well. So yeah, they're two, I think, great project examples of how we can pivot and adapt and continue to improve our resources. So we hope you enjoyed all of that. And then two quick things again, don't forget X/Twitter, whatever you'd like to call it. We're on there sharing our work. So we'd love to see you share yours. Hashtag IEDBUW 2023, and then tag us at IEDB_. And then we also did put in the chat the day 3 feedback survey. So if you'd like to open that and follow it along and answer as we go, you're more than welcome to as well, but we'll share that again later on. And now I will move into the Q&A because there's quite a few. So I'd like to welcome back Jay and Marcus. And Marcus, I think you should take the first question.
Sure. Denong Wang asked, I wonder whether glycan structure is included in SARS-CoV-2 spike. So that one that we used is the 70DD. That one, I don't think it is, there's any glycan included, but I know there's some structure available on PDB that has some glycan included on that SARS-CoV-2 spike. And also on IEDB, we have some epitopes that also has some modifier included, like has suffered like a glycosylation. So yeah, but for that example that I showed, it wasn't included, but we have some data available on IEDB and also on PDB about that.
Sorry, I was having a trouble getting back to my Zoom window. All right, so an anonymous attendee asks, are the rows returned for epitope query ordered by a specific property, e.g. random identifier date submitted? And I believe they are returned randomly if you do not select an order by clause. So you can add onto your query the way that you would like the results sorted. And that's actually critical if you're going to get paged results also. So the maximum number of rows returned is 10,000. And after that, it will start paging the results. And so you want to make sure that you use an order by clause if you're expecting to page through the results, and you want to get page, you want to go through page 1 and then page 2. You want to make sure that the results are going to be returned in the same order, so you need to use a order by clause. I forget what the particular keyword is, but it's in our documentation.
Okay, so Chongming Jiang, I'm sorry if I pronounced that wrong, but how can we get the structure from the peptide MHC from this tool? Thank you. So you can, I'm gonna share my screen quickly. So I hope you can see it. You can, on the assay filter, you can click it, select only MHC, and you can click in search, and it's gonna be available on the assays. It's loading, yeah, but it's gonna be available here on the MHC ligands assay, and you can click it through the structure assay and search, and you can filter only that assay that has peptide PMHC structure available. But I need to tell you that you cannot filter. If you're filtering for only MHC here, MHC ligand, it's not going to work with your monomer browser. Monomer browser, it depends to have like or T cell or B cell data. It doesn't work if you only have like MHC ligand data. So for the monomer browser, you should have it at least one of these two, T cell or B cell included. But just to visualize just use our 3D viewer, you can just filter here and go and open on the 3D viewer and see the PMHC 3D structure there, the viewer. So yeah.
All right. So John Altman asks, is there a PostgreST operator corresponding to something like homologous but not identical at a particular homology level? Unfortunately, no. So I know we have that functionality from the home page where you can blast at a particular identity level, but that's not something that's available through the PostgreST interface. You can do things like a like operation where you can use regular expressions, but we don't have a homology search. And that could be something that we could potentially add on by adding kind of a layer on top of PostgreST in the future, but no, that doesn't currently exist.
I think I have last one for me here. Oh, here we go. Leo, is IEDB 2.0 allowed to analyze an antigen in which the protein structure of the molecule has not yet available in PDB? Thank you. That was a great question. Unfortunately, no. To map the epitopes inside of the structure, we needed the structures available on or PDB web page or on AlphaFold database. So you cannot submit your own crystal and use this and analyze it using your own. Unfortunately, we needed to have published it on both at least one database to gonna map the epitope there and gonna show you the if you want to stay on the epitope, it's gonna be on the epitope tab or on the mono browser. So yeah.
All right. And so I'm going to answer two related questions here. One is from anonymous attendee. It says, if one wants to merge two tables, for example, T-cell assays and TCRs, are lists returned by both queries ordered in the same way? And the related question is from Hur Al-Hassani. Could we also combine multiple tables in one query? Say, find an epitope XY with binding affinity to MHC1 allele XX. And so, as I mentioned a couple of questions back, the results will be returned in a random order unless you specify the order that you would like them returned. So they'll be returned however Postgres sees fit. In terms of merging tables, yes, you can do joins in Postgres T, and there's some good documentation on doing that on the Postgres T page, and I believe we have a use case where we do that. I will check on that, and I can send out the link later today. Marcus?
I think you can take one or two more, and I'm gonna try to find if there's more for me.
Okay, the next question is from Darren Natale. It says, does the use of curly braces in the cs.search allow the user to specify multiple epitopes? I'm wondering why the braces are needed. Yes, it does. So you can do a comma separated list of the strings that you're searching for. And they have a couple of operators like that. So there's the cs dot operator, and also I think it's the cn dot operator, which is the contained in, which doesn't, strangely enough, doesn't use curly braces. One of them uses curly braces and one of them uses regular parentheses. But yes, you can specify multiple strings.
Yeah, I can. There's another one for me. So the anonymous attendee asked, it is possible to visualize a particular peptide in an O3D MHC structure to explore possibly binding interaction at amino acid level. That is also a really good question. No, for that, you needed to work a little bit with docking. We have some tools that can do this. We have a tool in IDB that is the doctope that can model their specifically HLA allele with the peptide that you wanted. So you can model that, but besides that, we don't have a tool to only replace the amino acid for the peptide and see how that works to analyze that. So for that, you should use it like some docking approach to make it work.
All right, and so the next question I see for me is from John Altman. It says, how do you handle MHC allele names in API queries? Do you need to escape characters such as semicolon or asterisk? Yes, you do need to URL encode the characters, any special characters that you use in the URL. The nice thing about using the Swagger documentation is you can just kind of, maybe I can show that real quick. You can type in, as you type the query, I'm just going to do some gibberish here because I don't know where I'm going to find the MHC name, but I'll just say, this isn't going to work obviously, but equals HLA-A*201, and then we'll see how Swagger renders that. Obviously the query is not going to work. And see, it automatically URL encoded this for me. So I guess the asterisk doesn't need to be URL encoded, but the colon does. And so a nice way to test that is through using the Swagger interface. Okay, that's this one. Okay, next one is from an anonymous attendee. would it be possible to add those links to API-related docs pages somewhere on the homepage? IEDB could not find a quick way to get there from the homepage. Actually, I'm not sure if they are there. I don't know if maybe Kelly or Nina can answer that maybe in the
This is actually a great point, and I've made a note. We'd previously, in our top red banner in the announcements, when we announced the API, included the link to the help article and the documentation page. And then since we've had new features come through, that banner has been replaced with other features. And it is definitely not super clear on how to access that API documentation. So I've taken an action and will definitely make that more obvious and easily accessible from the homepage. So thank you to the anonymous user.
Thanks. And yeah, and we had talked about at some point, I don't know if we still plan to do so, but we did talk about potentially when a user executes a query through the web interface to also provide the corresponding link to the API. So that is still on our back burner, and it would be nice to get in there. So thanks for bringing that up.
And while we're kind of on this topic, Jay's doing an amazing job of answering these questions live. And then we also have our Leidos software engineer, Kelly, who's adding some extra details via the typed function in the Q&A as well. So you want to take a look if Kelly's added anything else. Love the team effort. And
oh, sorry, Marcus, I see you have.
No, yeah, just Shola ME8 just asked the similar question. Are these documentations directly accessible from the IEDB 2 page? So I think the answer is no, right? But this is something like you should have more easy to find it. That's exactly what Nina was talking about.
And so the next question is from Oksana Lushenko. Thank you. Could you clarify where I can find the epitope sequences as queries? Where are these stored? Structure, description, linear sequences. And so it depends on the table that you're searching, but yes, in the epitope table, if it's a linear epitope, it's going to be in linear sequences. I believe it will also be in structure description as well. But Kelly might want to clarify in the chat. Thank you. And I see one more question from Hur Al-Hassani. If the query returns large records, can we do batching? In Python, it'll be something like get batch. Yes. And so actually you need to do batching because it will only return 10,000, the first 10,000 records that match your search by default. And so you'll need to use the paging operator. And so we have a write-up on this in the Zendesk article about how to do paging, and also in the use cases, especially in the Jupyter ones and in the R Markdown ones, we show you how to do batching in both Python and R. And then I see one more question from anonymous attendee. Is it possible to recapitulate the downloads, data dump CSV files from these queries? Not directly at this point, but we do, as I mentioned, we do potentially have plans to make that happen. So yes, I mean, it would be possible, but we don't provide a link to do that. Yeah.
Excellent. So Jay and Marcus, thank you both so much for demonstrating two really important features in the IEDB and for answering all those questions. Thank you so much.